Hello students, in this class we are going to talk about the main equations that governs the characteristics of uniform flow. So what is uniform flow? The main feature of uniform flow is that the depth, the water area, the velocity and the discharge at every section has to be equal or has to be constant. The energy line, the water surface and the channel bed are to be parallel, and if the lines are parallel then the slopes are equal. Okay, we will refer a diagram in the next slide. Uniform flow has constant velocity at every point of channel, and the flow depth of uniform flow is known as the normal depth. Okay, so and one more important point is that uniform flow is always a steady flow. A steady flow might not be a uniform flow, but uniform flow is always a steady flow. There cannot be unsteady uniform flow. Now, how does uniform flow occurs? The uniform flow occurs because when water flows in an open channel, there will be resistance. Okay, there will be resistance in the water, in the flow of water, but the component of gravity, okay, the water is having gravity, so because of this gravity the water is flowing. So when the gravity force will be equal to the resisting force, then that flow will be known as uniform flow. A uniform flow will be developed if the resistance is balanced by the gravity force. Okay, so this is the diagram we are talking about. See, the energy line, the water surface and the channel bed are all parallel to each other, and if these are parallel, that means the angle between the line is making an angle with the horizontal, and the slope, right, the slope will be equal. So these three slopes are equal because these three lines are parallel. So how is the velocity measured in uniform flow? The velocity is generally expressed by some empirical formula. Okay, we'll talk about this formula. In practical purposes, what we assume a natural channel to be in uniform condition. If only there is no uh, distinctive variations or visible variations, okay, or there are no flood flow, then and if there is no irregularities, then only we consider the channel to be uniform flow, and that formula will help us to find out the velocity. In uniform flow, since the velocity of flow does not change along the length of the channel, acceleration is zero. So we don't consider the component of acceleration. Hence, the sum of the components of all the external forces in the direction of flow must be equal to zero. So this is very important. Whatever forces uh, is acted upon on an open channel, all if we consider all the forces in one direction and we add those, it will have to be equal to zero. That is, it is following the law of equilibrium. As we know, in uniform flow the velocity is measured by some empirical formula. Antoine de Chezy, a French hydraulic engineer, he developed an equation. Okay, so let us go through the derivation of this equation. So we are considering an uniform flow of water in a channel. As the flow is uniform, it means the velocity, depth of flow, area of flow will be constant for a given length of the channel. So we are considering one length, and in between this length, every parameter is the velocity, depth, discharge, area will be constant. Here are some different parameters that they have taken. L is the length of the channel, A is the area of flow, I is the slope of bed. Sometimes this I is also taken as S. Please note that. V is the velocity of mean water, P is the wetted parameter, F is the frictional resistance per unit velocity per unit area. Okay, so what they have done, they have first found out the weight of water between the section 1 and 2. That means the weight the water is having in this particular section. So this is specific weight of water into volume of water, right? Which is specific weight of water means unit weight of water That is small w into area into length. Area into length will give us the volume of water. Now the component of W, that is the weight of water along the direction of flow, is W into sine I. Okay, I is nothing but the slope. The slope is given in angle. So if you refer to the diagram, you can understand. So W is nothing but small w AL. So small w AL sine I is the component of weight. Okay, because the weight is the water is having the weight, and it is a component of that weight which is along the direction of water. Frictional resistance against the motion. So the motion of water will produce some resistance. Okay, so that resistance is given by F, which is the friction factor, into the surface area into velocity squared. Okay, this N is always equal to 2 because it is experimentally found. So the friction which is acting on the surface area of the bed, the area of the bed. And why it is acting? Because of this velocity. So this is a relation they have established. Because of the velocity, there is friction which is acting on the surface. The surface is given by P into L. That means the perimeter into the length. The water is touching the channel on all the sides. So we will find out the perimeter, and we are having some length L. So that length is L. So P by L will give us the surface area. Hence the frictional resistance equation will become F into P into L into V squared. Okay. The forces acting on water between section 1 and 2 are. So what are the different forces? We have talked about the weight of water. We have talked about the weight of water. We have talked about the friction. And there will be also pressure force at 1 and 2. So we know there is no acceleration. So okay, we'll just go through this. As the depth of water at section 1 and 2 are same, the pressure forces on these two sections are same. Okay, and acting in the opposite direction. So the pressure forces, there will be pressure forces at both the section. So this is the flow of water. There will be pressure force here, there will be pressure force here, but this will be acting in this direction, this will be acting in this direction. Hence they, what happens, it cancels out. Hence they cancel each other out, so we don't consider it. But there is, in reality it exists. Okay, just for our analysis we are not considering it. Okay, so if we resolve all the forces, that means this is weight of water in the direction from left to right. Okay, we are talking about only one direction, resolving all the forces in the direction of flow. This is FPLV square. This is minus because the friction is always will be opposite to the direction of motion. So this is minus. This minus is coming. Hence it is equal to 0. That means finally we are arriving at this equation. Now if we simplify it, we get a very important relation. Okay, V is equal to root over W by F into root over A by P into sine I. Okay, I is the slope. Once again, I'm reminding you. Then A by P is known as M, okay, which is the hydraulic mean depth or hydraulic radius. A by P. That means area, flow area. The water is having some area. Area divided by the perimeter will give us the hydraulic radius or the depth. Now this relation root over W by F is known as Chezy's constant, C. It's very important. It is governed by two things. One is weight of water, another is the friction. Okay, this friction will again depend on various things like roughness of the bed and different things. Okay, so mainly this is our equation, Chezy's equation, which is giving us the velocity, right? So this is giving us the velocity V. This is the Chezy's constant, and definitely we can find out the area, sorry, the discharge Q. The discharge Q is area into velocity. So area into velocity is this. So AC root over MI. Okay, very important relation. Do remember this relation. So I have just taken a problem from the book RK Bansal. So we'll just go over this numerical. Here the velocity is to be found. Okay, the rate of flow of water through a rectangular channel of 6 meter wide and 3 meter deep. So a rectangular channel is given. So this is water. Okay, the channel will be like this. Okay, but this is the flow depth 3, this is 6. When it is running full, okay, actually this is running full, so we will say that this is running full. So the full depth of 3 meter, there is water. The channel is having a bed slope as in 1 in 2000. So this I, okay, or S is equal to 1 by 2000. Okay, this is 1 by 2000. Take the Chezy's constant as 55. So the Chezy's constant that we have found out, root over W by F, is 55. It is given in the problem. So we'll find out the area. Okay, Chezy's constant is given, perimeter is given. So we just need to find out this one, right? We just need to find out this one. So to find out M, we need A by P, right? So 1.5 meter, and we'll just put the equations, put the values in the equation, and we'll find out this relation as meter per second because we have taken meter. Also, the rate of flow, which is a discharge, is also found out, which is nothing but the velocity into area, right? So this is area is also given 18. We have found out the area, so this is the rate of flow or discharge. Another problem you can just go through. Okay, I will not explain this. This is nothing but a trapezoidal channel. So in the same manner, you just have to find out the discharge this time. So if we find out the velocity, you can easily find out the discharge. So discharge is found out. Now in this two problem, the value of C is given, right? The value of C, it has been determined, it has been given to you. So if it's not given to you, how will we determine it? Okay, so for that we have to look into some different empirical formula. Okay, so we know Chezy's formula we have seen, which is, what was the Chezy's formula? C root over, right? C root over mi, is it not? C root over mi. So he was a French engineer, Antoine Chezy, who developed this formula in 1975. In this equation, C is known as Chezy's constant, which is not a dimensionless coefficient. Very important. The C is a coefficient, but it is not a constant. Do remember, C is equal to root over W by F. It is depending on something, right? So it cannot be a constant. It is depending on the friction, weight of water. This may be constant, right? This may be constant, weight of water, but this friction is not constant. Hence, this C is not a dimensionless parameter. It is not constant, it is changing. So it is not a dimensionless coefficient, and this is the dimension of the Chezy's constant. The last line, hence the value of C depends upon the system of units. The following are the empirical formula after the name of their inventors used to determine the value of C. So this we will do in the next class. Okay, so there are different scientists or inventors who have found out the value of C by some experiments. So those we will talk about in the next class. So I hope you understand. I hope you understood what I have taught today. So let us move on to the next class. Okay. So I think if you have any doubt in the class interactions, we can talk about. Okay. Thank you very much. Take care. So yeah, assignment also you have to do. So I'll be providing the assignment in Google Classroom. Thank you.